obviously every civil engineer should have a little, not little, more knowledge about this column. So on that concept, just I wanted to give you overall idea at least today. Maybe we can discuss, or we have time next time when we do the problems and the examination point of view, right? So that we will see. But at least can able to say at least the idea point of view, concept point of view today we'll discuss based on the time available and all. So at least what is the column? Suppose when we say everybody knows that the column, everybody hear that name is column easily. But first we should know exactly meaning of the column and what is the practice basic principle of a column. Then we can understand more easily the problems and the concepts, visualization and all, right? So just I have just given us some figures. At least somebody can able to visualize what is the column, and also given us some words here. Just I will read quickly, so that after that I will explain more detail, right? So column is a vertical member, structural member. Please remember, column is a vertical structural member subjected to carry axial load and bending. If somebody has put this open this mic, can you able to unmute your mic, so that not be disturbance to everyone. Whenever you wanted to speak, unmute and you can able to say, no issue at all. But when I giving the lecture, it is better to unmute your mic so that no disturbance. Very good. There somebody has stopped. Okay. So now again I am just reading this. Column is a vertical structural member. Please remember, vertical. Not every vertical member we cannot call it as a column. It should be vertical structural member subjected to carry axial load and bending. So this definition also you may get everywhere, but we have to understand each and every word of this definition. Then only you will get to have more visualization, more understanding about the column. Okay, structural member. Everybody know what is a structural member. Structural member is nothing but a member having some loading acting on it, that we call it as a structural member. So again, carry axial loads. As you know, I think I have many classes, at least in the class, maybe other topics I have explained. I hope I'm not sure, but I remember I have explained in the class. Axial load. Axial load is nothing but the member, suppose is there. So suppose this is a member. So this is a beam, suppose, what are maybe. So beam or column is a structural member, obviously. We know beam will be the horizontal member and column is a vertical member. But axial load can be act in any member, as a horizontal member or vertical member. So when we call it as axial load means, can you able to see my screen also? I mean not screen, my visual, my whatever I giving the lecture, my face. Not clear? Anybody can unmute? Because only
Yes,
screen you
sir.
can. Okay, my short
Yes, sir.
screen you can
Yes,
able to
sir.
see me. Yeah. If you see what I am
Yes,
telling
sir.
is, this is the beam, right? This is the structural member. So what when we call it as axial force is, suppose the force is acting along the length of the member. That we call it as the axial member for a beam. Similarly, it is a column, it is a vertical structural member. The force is acting along the length of the member. We call it as the axial member. Okay. Next, what is the bending? Bending, everybody know. The bending means when it is happen, when there is a shear force acting on the member, it will be try to bend. That will call it as a bending. Please remember, this is axial force always along the length of the member, shear force always along the axis perpendicular to the length of the member. That is shear force, and axial force is always along the length of the member. Please remember. With that I will proceed further. The cross section dimensions of the column is large. We see there is a difference between the column and strut. Both are, we call it as the structural members, but in the column, if you see, when we say the column, when you say the strut is, column means always the length of the member, the cross sectional dimension, sorry, not only the length, cross sectional dimension of a column are large when compared to the strut. Not another property is columns can carry heavy compressive loads, very heavy compressive load it can able to carry. Then we call it as a column. The columns are used in concrete building as well as a steel building. Please remember, somebody of at least in students, it will confusion. Column means always a concrete member. No, that may or may not be. This is also will be, we can call it as a, just, just, yes, see, this is a concrete member. Call at the same times some steel members also we call it as a column if exists this property. That means that suppose ISMB something we are using as a steel, that also we call it as a column. Not that doesn't mean that only concrete will be there, then we call it as a column. So please remove that confusion. Any member you can to have carry the axial loads and bending we call it as a compression. I call it as a column or compression member, whatever may be. Next, so that's why I said is both the concrete and steel buildings it will be used. Next, also it is the lateral forces also. Please remember, column along is acts axial force, as also we have bending and lateral forces. Lateral forces means suppose column is like this will be acts the lateral forces is nothing but the shear forces of the column. We call it as a lateral force. This is longitudinal force and this is the shear force, right? So that also it will happen in the column due to the, but if you see practically column always takes the vertical loads in practical case. But how you will get this what you will call it as a lateral forces means during the wind force, right? Wind is act like this, so obviously it will act in the lateral direction. Wind or earthquake also it will be act in the lateral direction. Normal weight of the building only along the length of the member, that is axial loading we call it as. Next, we can see frequently we can use the beams and arches, which is a part of the wall and ceiling. Right? Normally, what is the purpose of the column is mainly, what is the purpose? We everybody know the load carrying from the slab, beams, everywhere. Finally, it will go to the column and column to the foundation. So that is the main purpose of the column is load will be take care from all the beams or slabs or arches, and finally it will take care of the, it will transfer the loads to the foundation. That's normally columns may be fixed or hinged. Please remember, whenever we will put it as a fixity, then only we will call it as a column. No, it may not be. Depends upon the boundary condition or given fixity. Even the hinge condition also we call it as a column. So, but how the differentiate between the load transfer and the hinge and fix, we'll discuss maybe in future classes. But I don't want to confuse more on that topic. But only basic concept today's class we will going to discuss. Right. So next. Yes, so this will be required more idealization. Sometimes many of you have little bit confusion between the column and stud. So we will discuss little bit more. I will like to give you more idea of the column and stud is, because many times column and stud looks like the same, but little change its behavior, then we call it as a stud, and otherwise we call it as a column. See, here I have shown few examples so that you can able to visualize which member we call it as a column. But many of you students have little confusion. Column we have maybe only the vertical, not column. Stud will be the only vertical member. No. Sometimes based on the action of the member, we call it as a stud for horizontal member, or inclined member also we can call it as a stud. I will tell you some more example from here. You see here, there is a flag. Is a flag is Indian flag as there, whatever countries is there, it is resting with a one vertical member, and the two are supporting as a brace. We call it as a that brace or tie, whatever may be. What is the purpose of these two members, inclined members, is to just to overcome, reduce the vertical deflection. Because if we have not have a tie, what happens, it will try to bend like this in this direction or in this direction. To avoid that, only generally we will use the tie members. We call it as a tie member. So in this figure, if you see, two wires are the tie members and a vertical post is there. But in this case, we should not call it as a, please remember, we cannot call it as a column for this member. We call it as a stud only. Because why it is a stud? As I said, it is a stud column. The fixity may not be there continue. If your concrete is fixed, I mean to say fixed condition is there, when simply call it as a column. But here it is not a fixed condition. It will have to have a position to move all this direction at the top, at least top or bottom, easy to move. So that's why we call it as a stud in this case. But stud is a member subject to axial compression force. Stud may be vertical, horizontal, or inclined. The cross section dimensions of stud are very small. We see normally if you have a column in this much big, there should be a dimensions of cross section will be the more. But here cross section, we know small rod is there, will as a put it as a flag, right, for a vertical post. That time we call it as a stud, not a column. Please remember, cross section should be less. That member we call it as a stud. Suppose here in the second figure you see there is a beam is hanging with again the tie. The purpose of the tie, always remember, is the same. Either maybe horizontal beam tie or column tie or stud tie. Always it have to be gives little rigidity to the beam to reduce the deformation. That is the purpose of the tie member. So here if you see this beam is in this direction, but the tie is provided something like this or lateral tie. In this case, what happening is, even though this is the beam, we can call it as a stud also, right? Why means the dimensions is very less of this beam, right, when compared to the normal cross section. So that's why in this case we can able to call it as a beam or stud. right, in this case. But again, next you see the next member, even that sometimes, as I said, that one, this may be inclined also sometimes. See, but column cannot be called as inclined, and horizontal we cannot call it as a column, but stat may be horizontal or inclined or vertical. Any member we can call it as stat if you satisfy these conditions. See here what happens is, here in the third figure, there is a horizontal beam, it is there, and the two inclined beams are there, or inclined members. I cannot also call it the beam, is a members. So what happens is, suppose there is a load is applied at the top, it will have try to take care of this compression and tension in this property, and the both inclined members take care of compression, and at the same time the bottom portion will goes on tension, right? So tension in the member, always please remember, don't confuse. I'm talking not about the joint, I'm talking about the member. So always the member compression will be shown inside to arrow, arrow to arrow, right? But tension means outside, we are pulling, right? Please remember, don't confuse which is compression, which is tension in the member as joint. Both will be little bit confusing, so forget about the joint. If you see that arrow to a joint, it will act as a compression, but forget about the joint, we talk about the only members within the member. So within the member, these two members are called inclined members. We call it as a stud, and the horizontal member is going to as a tie member. So that's what I wanted to say is, the column and stud I have a little difference. Whenever we say the column is cross section should be more, and the stud means cross section may not be the more, but it will take care of axial forces mainly rather than pure bending. So please remember that, so then we can able to easily identify what is the stud, what is the column. Okay. With that, I am proceeding further in my next lecture. Yes, next we every time little bit confusing having the when, so now till now we have what we discussed is what is the difference between stud and column. Now we'll do the in the column itself. There are two cases are there. Sometimes we call it as a short columns. Sometimes we call it as a long columns. But when we call it as a short and when we call it as a long, we can know you also studied. But that is that's why I'm not giving that much time for that. Everybody just definition you can easily understood, because when we call it, I'll quickly go through this one, so such that we can able to clearly you can able to understand. So see, this is a column is a compression member, may be classified into following two types depending on the slenderness effect. Slenderness, please remember, slenderness effect. What is the slenderness? We will just discuss again clearly about what is the slenderness is. Slender is nothing but a geometric property of a compression member which is related to the ratio of effective length to its lateral dimension, right? Effective length to its lateral dimension. So we everybody know what is effective length. Again, we will discuss more if you go to the next slides. Effective length, what is effective length all? So everybody just give this effective length, effective length, but there should be proper meaning for that. I will tell you later when this says. But when we say the slender means the member which is going to the bending or buckling, we call it as, then only we call it as slender member, right? So I will not take much time. This is everybody's knows, so not have only concepts. I just wanted to be, yes, here. Okay, just as we already just defined the slenderness ratio, this will be nothing but the effective length of the column by minimum radius of gyration, minimum radius of gyration. Normally everybody knows this. So, but here this formula only given. So, but if you see that something like that radius of gyration, we should know the meaning of what is the radius of gyration, right? Obviously, we should understand what is the radius of gyration. So everybody can able to see this is different formula is directly known I by A, right? So, but we should know square root of I by A, we call it as a radius of gyration. But what is I? But related to the material property, both are material property. I is the moment of inertia, A is the cross sectional area. If we give the ratio of that one, we will put a square root, then we will get the radius of gyration. So generally, this is also radius of gyration is nothing but is also the property. We are just what we are doing, giving the ratio of the two existing properties. We call it as a single entity. That's why it is also the property. Instead of getting two different variables, we wanted to use one variable. That's why we have made this radius of gyration variable with respect to the two other variables, that is I and A. That's it. So here if you see, but this effective length, yes, what we are telling is the effective length. So generally, what is effective length? So if you see, we have different values for different support conditions, but we can everywhere anywhere we can get these values. But my intention here is why it is happening. They have a different effective length for different support condition. That we have to be get little idea on that focus, then we will get a more concept on concept wise you can get little more understand what is the effective length. So if you see first what ISN is consider the boundary condition is both ends are pinned. What does that mean? Pinned means it can able to rotate. Rotation may be possible at where only the horizontal and vertical reaction will be there. It will cannot able to move horizontally and it cannot able to move vertically, and then but it rotation will happen. That is the meaning of pin, right? Everybody should know. So what happens is here both ends are pinned. That means the rotation is possible. If you see that we can able to rotate like this or rotate like this, but if whenever the force is there, it will not go inside. Horizontal force is there, it will not move in this direction. But rotation is possible. So if that is the case, what happening is, if it happen, the normal length itself is the effective length. It will become, because we are not the see column is not able to reducing its length any effect, because only the force wherever whenever the initial position, if we apply the loading also, it will happen in the same, but the effective length may not having any change in this physical position. That's why we consider as effective length is equal to L is equal to L for suppose both ends are the pinned condition. Suppose second case, we consider both ends are fixed. So what is the difference between fixity and pinned? We already knows that, already explained many times. So what is fixity is nothing but it will not move in this direction, it will not move in vertical direction, and also it may not able to rotate also. That we call it as fixity. So earlier case I have just kept in this same like this, so that the effective length is become a same normal L. In the second case, what happens? Fixing condition. That means we are holding this entire support top and bottom such that it cannot able to rotate also. Right. So in this case, what happening? Holding effect will be some more top and some more bottom. So what happens? Effective length is only whatever the remaining length in between will be the effective length. Right. So that's why if you see here the fixity, we can able to say effective length only half of this portion we consider 0.5 L. That is the reason we will use the fixity for the effective length for a fixed case is 0.5 L. Right. So you understood now what is the difference between the pinned and fixed case. What happening is fixed means we are holding. When we hold, then only we call it as a beam is a fixity. So whenever we're holding up to this portion, we are not able to at all, cannot able to anything deformation. Only the middle portion remaining only can able to deform. So that's why we are showing like this. 0.5 L is considering up to whatever the length is L, in that only 50% of length we consider the effective length for that case. Next case, third case is what happened. One end is fixed, other end is pinned. Same thing, if you understand the concept of pin and fixity, you can easily remember these values. No need to by heart and all, right? So in this case, third case is happened is what happened, it is a mixture of both two, first and second case. So what happened is one end is fixed, other end is pinned. So what happened, one end I am holding, third end only just I am putting like this hand. So what happening, the effective length is this time in the bottom side it is reducing the length, but top side as it is. So that's why you will having the 0.7, and sometimes in some codes it is 0.75 also. But please remember, he said only one side only you are getting fixity. So one side only you are getting the less length, but remaining hinged portion or pinned portion you are getting the same length. So that's why only the effective length will become here 0.7 L. It is not the full L and not the 0.5 L of the fixed case in between, because only one end is said holding. Right? Hope you can understand. Next case, this is a very important. Here case, what happens is one end is fixed. Okay, we are holding something, but top is entirely free case. Free case means we are not at all this one holding also. Earlier pinned case, at least we are holding from the horizontal and vertical deformation. Here it is entirely free. So that means this case. Yeah. So what happens is when anything load is happen, it will be something bend like this. So entirely it will bend. Earlier case, pinned case, please remember, it is only rotation is happening, but is not able to bending. But in this final case, free case, what happening is what even though bottom is fixed, top L is entirely free. So what happening, the length is increasing drastically, because length effect is increasing drastically. So that's why we call it as in this case happens is L is equal to 2L. So this is the worst case, I think, right? So that means we are giving very freedom to the column, so we can able to move anywhere. So in the top side at least. So that's why we have to consider as a 2 times of effective length. That is the reason these are the main concept wise. These are the things. If you are able to imagine what is happening here, then you can able to understand why this value is 0.5, 0.75, 2L. But in the textbook everywhere you can able to see these values, but you cannot able to visualize why this is reducing. That is the reason I have explained more clearly now why it is happening, right? because of that I shown this example with my demonstration, right? I hope you understood, right? And I am proceeding further for that next topic. Yes, it's the same thing. Here also I have done the same, but we have properly, I have shown the, I can say boundary conditions, how we can able to show fixity, how we can able to show the pinned condition, and how we can able to the free condition. So if you can see the code IS456, you can able to see exactly this type of presentation. But don't confuse whatever a basic concept I have explained is the same applicable for this also. As, in the earlier slide I have explained for 3 cases, but sometimes practically what happens is it may able to get more cases, because what happens is, but in practical we cannot able to exactly fix any point, or we cannot able to consider any pinned, little bit of mixture of fixed and pinned, or pinned and free. In that way they are expanded in a number of more cases, but the entire concept what we discussed is the same. Whenever the fixed is there, we are holding, so reducing the length. Whenever is a hinged is there, we are just putting the hand with the normal condition, and whenever is a free, we are removing the hand and it will able to rotate. So please remember these 3 cases: pin, fixed, and free. You can able to enter, you can get to understand what is exactly thing, right? So fine, I think that is the only thing is here given more cases, because sometimes what happens is more practical cases may possible. Theoretically we can able to say only the pinned and free and fixed, but sometimes what happens is it is possible for a mixture of cases. So that is the reason here can see we have the experiments are explained. Based on the experiments these values are came finally there are. But the concept is here, whenever the free is there, obviously the more value will come as the effective length. Whenever fixity is there, will be less value of the effective length. In the pinned means is the average value or normal value. Please remember that. Okay, next, this is a very important concept. Many students have a confusion of this one. Even many of you experts also a little bit confusion about this property. Many of you feeling is the thing. So just I wanted to clear this concept. Mainly column is this concept, I'm telling you. Mainly column depends on this concept. If you clear this concept, you can enjoy the learning, or you can able to understand the normal difference between the beam and column, right? So I will just try to give you more a concept on this point. So here just this is the buckling, right? So just first I will read quickly, then definition, then I will explain more elaborately, then you can understand exactly what is there in the buckling, when we call it as a buckling, right? So if you see here, buckling is a failure mechanism for a compression member that occurs prior to yielding of a material, right? So definition, once you read, you can 50% you can understand per definition by reading the definition, but we have to understand it properly. Just you have to be a little bit here about what are the other topics and all. Okay, here I want to explain again. Buckling is a failure of mechanism for a compression member. Please remember, buckling we call it as that word buckling. It should be the compression member. It should not be a tension member. We cannot able to call it as a tension. Compression everybody knows, right? Compression means towards the body and we'll push. This is the push, and tension is the elongated above the above. It's pulling in this direction, right? So in this case, what happens is here I defined compression member occurs, compression member that yields. What is meant by yielding? Everybody's known what is yielding. Yielding is nothing but changing the diameter of the member at the time of loading. After the time of or during the loading, we call it as a yielding. Yielding means changing the diameter. Suppose what happens is you have compressed something, some portion you will get the change diameter. Normally entirely one diameter, but at the portion where you are compressed centrally or somewhere, you will get a different diameter. It may be tension or compression, but we call it as a yielding, right? So same thing, I think you might have seen in this SM lab, you might have done some yielding of a steel. But here tension test of a steel. What happens is it will, when you apply the tension to the steel material, it will try to elongate. That time the center portion of the material will less the diameter than original diameter. That type of property we call it as yielding, right? So here we can say again, now we got the what is yielding, right? And yielding this. So please remember here, we what happens is I think again the time, again the free time we are using that Zoom. So another 10 minutes is going to close, but again please be and connect again. I will be again back after whenever it will close, right? So we'll continue the session, don't worry. Next, if you see here, buckling is characterized by sideways or failure of structural member. Again, more clarity on the buckling I am reading. So then again, don't worry, I will explain properly. You will get clear understanding what is buckling in the next slide. So buckling is characterized by sudden sideways failure of a structural member. subjected to high compressive stresses. Please remember, as I said, it is a compressive. Only buckling we call it as only the compression is happen, not for the tension case, right? So an applied load is increased in the member. So in a column will ultimately become a large enough to cause the member become unstable and is said to have a buckle. So same definition why I'm explaining little clarity. So whenever if you see whenever there is a compression member is there, what happens? The load keep on acting on the member, right? It will keep on acting on the member. So I will show the refill so that it will clearly see that what is the buckling exactly. But see, so this is the column, suppose, right? This I am applying a compression, right? I am keep on applying. So I keep on applying, keep on applying. So what happens is after some extension, it will try to bend. I will not call it a bend. This is a buckle. So what happens is this column is buckling now. So if you see, okay, able to clearly see the column is buckling. So but the load is, you see, I have applied only compression only. I not applied any shear force or lateral load. Only vertically only applied. But still, if you see that the column is changing its deforming. So we call it as that. We call it as a buckling. You understood what he is saying? So can I able to visualize clearly now what I am showing? Right? So is please, so I am not applying the lateral force. Lateral force is nothing but perpendicular to the member. Don't confuse. This is not, I am not applying any member. I am only applying the lateral load, but not lateral load, sorry, axial load. But still the column is behaving like that bending. Right? So this type of behavior we call it as a buckling. So if you see that example in the my shown picture, there is a steel column, there is a concrete column, both are there, right? In the steel column, what happening is if the column is the load is compression only. Please remember here there is no horizontal loading, only vertical loading only, that is from the weight of the structure, right? So due to that, what happening, same what thing whatever I have explained, the same thing is happening here. I mean, this is like this. So what happening is bending like this, and finally what happening is this, finally it is buckled. So one stage is reached that loses the property of the column. So that is that after that, if it will fail, we call it as a failing that mode. It may not have exactly become two parts, but at the same time it will be could not be used as a column. So that means load carrying capacity, it will be loses. So that type of thing we call it as a buckling. So if you see the same thing I have shown in the steel column as well as a concrete column, how the buckling will be practically, it will be visible if you happening the buckling, right? So this is we call it as a buckling of the column, right? So everybody clear now, and I will show you next slide. You will get more idea of the, many times people generally students will confusion between the what is the bending, between the bending and buckling. Please remember that is a very close difference is there between the bending and buckling. If you not understood, please ask me again, I will clear. But it is required for a column is very, this is the only difference between the column and the normal beam. So I will show you more quickly in different way. Yes. So then we will get more idea of what is bending, what is the buckling. See here, here if you're seeing some beam and column, right? So, but both are the compression members. Don't see it. Both are the compression only acting. But if you see beam is something like this, the force acting is perpendicular to the member. Please remember the member, the load is acting perpendicular to the member. So if the member is deforming, right? Here deforming, that we call it as a bending. Please remember the force is acting perpendicular to the length of the member. We call it as a bending here, right? Suppose if you can able to see a same member in a vertical member, we are having the member. The force is acting along the axial direction. That means along the length of the member. We see the force acting along the length of the member. It is bending. That not bending. If it has a deforming, in that case we call it as a buckling. Right? I hope now you can get a more idea what is the difference between the bending and buckling. Here, please again, I am repeating. In the bending, what happening is force applying in the perpendicular to the member. Member is like this. It may be a beam or column, but bending normally beam may not able to call it as a buckling, because if you force is applied here, normally beam will neglect the axial force in the beams. That's why we never consider the axial forces in the beams. But columns is the axial force is the main criteria, so that's why we call it as a bending, not the not buckling, not the bending. I hope clear. So if we have anybody still have confusion, please let me know. This is a very important topic, and this is the main difference of between beam and column. I can say as a structural point of view behavior. Anybody having a doubt, still have a confusion, please let me know. I'm ready to again explain also, but it's very important. That's what we cannot able to clear anywhere in the textbooks, not that much. Only they will give definitions and all, but more understanding is required. We have to visualize, right? So that's why I always try to show the visualization. Always, end of the day, we learn from the visualization. Any students have the doubt between the still, bending, and buckling? Okay, I think no doubt seems to be that's why. If anytime, any doubt, please unmute and ask. Huh? Don't worry about this. We have to learn. End of the day, we have to learn. Not like that something. I think
Sir,
session also. Hello, yeah, somebody is asking doubt. Yes, very good.
repeat once again, sir.
Yeah, yeah. Who is that? Is Narayana? Lakshmi Narayana?
Yes, sir.
Okay, very good. Okay, I identified your voice. Very good, at least. So even though if the session will close, please stay and connect back. We will again discuss. The time is, I think, another few minutes. It will be closed because we are using the free version. So don't worry that, but we connect again and we can talk about. Okay. So what I'm saying, the difference between the bending and buckling is, suppose the any member, we consider beam or column, anything. This is the member, right? So this you can able to see. This is the member. There will be the two types of loading may act. What happens? One time the force may be load may be acting perpendicular to the member. So this is the member, this is a perpendicular to the member, and another force will be the along the length of the member, along parallel to the member, or along the axial direction of the member. Anything. This will be the one member, one force may be possible, another force is possible in this direction, right? So suppose if the force is acting along the perpendicular to the length of the member, so this is the length of the member. Everybody knows, right? So this is the length of the member, and suppose if a force is acting perpendicular, so once this is a perpendicular member, perpendicular will be the 90 degrees of this member, right? This is the 0 and this is 90 degrees angle. So if the force is acting like this, it will behave like a something, it will deflect like this, right? So that's what I have shown in the first diagram. So force is acting perpendicular to the member, that we call it as a bending, normal bending. We know if it is beams and all, bending moment and all, we call it as a bending. But if you see the buckling, what if you say is, suppose I will talk about the same example in the beam case, then I will come back the column case. What if a beam case itself? So if we call it as a buckle, when we call it as a buckle is, the force may not act in this direction. Now, please remember, whenever the force act along the length of the member, here it is a beam, so force should be acting in this direction and it will bend, then we call it as a buckle. Please remember, just forget about the second case of the column case. Only first beam case itself would be clarity, then it will be applicable for the column. So beam case, what is, please once see, once is the perpendicular load is happen, it is bent, and another is along the this force direction will be act in this direction, it will also bend. So when the force is acting in this direction, it will deflect, we call it as a buckling. When the force is acting along the perpendicular to the length of the member, it will deflect, then call it as a bending. So now it's clear.
Yes, sir.
Right? It's clear. Just don't confuse. Just based on the position of the loading, we call it as a differently. That two names. The finally both this is bend. This is happening deformation only. But the we call when we call it as a bending, when is buckling is the based on the load it will act. Suppose the load acts in the perpendicular case, we call it as a bending. Load acting parallel to the member, then it will deform. Then we call it as a buckling. So similarly, if it is a column, column always vertical member, so it will act. Suppose the load is acting axial member, column is the axial member, right? So obviously what happens is the load is acting along the length of the member, it will bending. So that sorry, it is deforming, that we call it as a buckling. Suppose the force is acting perpendicular to the member of the column case. Please remember. If this is a column, the force is perpendicular means in this direction. In this direction, if deform is happen, that we call it as a bending. Right? So I hope you clear this one. I think soon, I think within less than 1 minute, the session going to close, and we will again rejoin. Plus, please connect everybody. Yeah. So